Welcome, everyone, and get ready, because we're about to take a deep dive into a topic that might just totally flip your understanding of reality. We're going to be talking about dimensions. Specifically, we're going to be looking at this really interesting piece called Dimensões Além da Imaginação. Você Vive, Não Sabia. Oh, which translates to dimensions beyond imagination. You live in 4D and didn't know it. Huh. To get us started, I want you to think about something for a second. Remember those old-school 2D video games like the original Mario, where everything is flat? You can only go left, right, up, or down. Now imagine if Mario suddenly jumped into a 3D world. Can you imagine what kind of perspective shift that would be for him? That's kind of the leap we're going to be making today, as we try to answer some pretty big questions, like why do we even see the world in 3 dimensions to begin with? What exactly is this mysterious 4th dimension that everyone keeps talking about? And could we actually already be living in it without even realizing it?
This is a pretty fascinating journey we're about to go on. Instead of just accepting this 3D world that we experience every day, we're going to push the boundaries of what we think we know.
Yeah.
Kind of like upgrading your understanding of how the entire universe works.
I love that. Upgrading our understanding
Yes.
of the universe's operating system.
Yeah.
Okay, so let's start with the 3D world we all know and love. For centuries, that was pretty much all people thought there was.
Yeah.
I mean, we can thank Aristotle for laying down the law with length, width, and depth. Then the 19th century rolled around, and this mathematician named Bernhard Riemann, he threw a wrench into things. He said, what if space itself is curved? And that opened up this whole can of worms about there maybe being more dimensions than we can actually see. Then fast forward to the early 20th century, Einstein bursts onto the scene with his theory of relativity and introduces this whole concept of space-time, where time itself becomes the 4th dimension.
And the important thing to remember here is Einstein didn't just add time as an extra thing. He basically wove time and space together to make this inseparable thing called space-time. And that's a huge shift because it means that time isn't just something separate from the world around us.
Right. This is where my brain starts to feel like a tangled up slinky. So to help us wrap our heads around all of this, maybe we should break it down dimension by dimension, like building a house, starting with the foundation.
I like that. Okay, so imagine the most basic building block you can think of. A single point. It doesn't take up any space at all. That's the 0th dimension. Now, let's extend that point out into a line. We've got length, and that's our 1st dimension. To get to the 2nd dimension, let's add some width to that line. Now we've got a flat surface, like a square. And finally, let's give that square some height. Now we've got depth, and we've arrived at the 3rd dimension, which we can represent with a cube.
Okay, I'm following you so far. But how do we take that 3D cube and jump to this 4th dimension of time? It's not like we can just add another side to the cube, right?
It's true that visualizing higher dimensions can be tricky, especially for us 3D creatures. Take the tesseract, for example. That's the 4D cube. We can't actually see a tesseract in our 3D world. All we can see is a distorted shadow of it, kind of like how a 3D cube casts a flat shadow on a 2D surface. But even though we can't really picture it directly, this 4th dimension is all around us. We're moving through it all the time.
Hold on. Are you saying we're already living in 4D, but time feels so different from length, width, and height? It's not like I can just point at it or walk around in it.
That's the really mind-bending part. This source material is basically saying we already inhabit the 4th dimension. And it's time itself. Everything around us is constantly moving through time. It's not just something we measure with a clock. It's a fundamental part of reality, woven into the very fabric of existence.
Okay, so I can't see it or touch it like you can with the other dimensions, but we're always moving forward through it. I guess it's more like a river we're all floating down, rather than a space we can explore.
Exactly, you're getting it. And just like a river has currents and eddies, time is more complex than we might think.
Like how?
Well, there are areas where time flows faster or slower, and even places where it seems to bend and distort.
Wait, hold on. Are you telling me time isn't always constant?
Yeah, it might sound strange, but it's one of the most fascinating discoveries of modern physics. Time isn't this rigid, unchanging thing. It's dynamic and fluid, and it's deeply connected to the universe itself. And that brings us to one of Einstein's most mind-blowing ideas.
Okay, I am hooked.
Yeah.
Lay it on me. What is this mind-blowing idea?
It's called time dilation, basically. Einstein's theory of relativity showed that time can actually stretch or contract, depending on things like how fast you're moving or how strong gravity is.
Wait, time can stretch, like a rubber band.
Kind of. Imagine you have 2 clocks, one here on Earth and the other one on a spaceship that's flying super fast. The clock on the spaceship would actually tick slower than the clock on Earth. Time itself is literally passing at a different rate for the 2 clocks.
Okay, My mind is officially blown. But why would time slow down on a spaceship just because it's moving fast?
Well, that's where things get really wild. According to relativity, the speed of light is constant for everyone, no matter how fast they're moving. So to make that work, time itself has to adjust. It's like the universe is doing this crazy balancing act to make sure the laws of physics work everywhere.
So the faster you move, the slower time goes for you? Compared to someone who's standing still? That is so bizarre. Does that mean astronauts actually age slower than us down here on Earth?
Exactly. The difference is really tiny at the speeds we're used to here on Earth. But if you could travel close to the speed of light, time dilation would become much more noticeable. And it's not just speed that can warp time. Gravity does too. The stronger the gravity, the slower time flows.
Wait, how does gravity slow down time?
Okay. Think of it this way. Gravity is basically a warping of space-time itself. Really massive objects like planets and stars. They actually create like a dip in the fabric of space-time. And the deeper that dip, the slower time flows in that region. It's almost as if gravity is pulling on time itself, causing it to stretch out.
So time is like cosmic taffy. Gravity stretches it out, and speed kind of squishes it together.
That's a good way to think about it. It's definitely a mind-bending concept. But it's been proven over and over again through experiments, and it's one of the most important ideas in modern physics.
Okay. I need a minute to process all of that. So we've got time dilation from speed and gravity, and we can kind of visualize time as part of this fabric of space-time. But what does it actually look like to move through this 4D world? Is it anything like what we see in sci-fi movies?
That's where this idea of a world line comes in. In our normal 3D view of the world, we see things moving through space. But in 4D, we would see objects tracing paths through space-time, like these continuous lines that represent their entire history. Imagine a car driving down a road. From our 3D perspective, we just see a snapshot of the car at any given moment. But in 4D, we would see the car's entire journey through time, all at once, from where it started to where it ends up. That's its world line.
So, if we could somehow step outside of our 3D view of the world and see the universe in 4D, we would see every object's entire timeline all laid out.
Exactly. It really makes you think about the past, present, and future in a different way. Our idea that time is linear, with a clear separation between those things, might just be because of our limited 3D perspective. Maybe from a higher dimensional point of view, all moments are actually happening at the same time.
Ooh, so you're saying that everything that's ever happened or will ever happen is already out there somewhere, woven into this fabric of space-time.
It's a pretty mind-blowing idea, and it shows just how much we still don't understand about the universe. What if we could unlock the secrets of higher dimensions and experience reality in a whole new way?
That gives me chills just thinking about it. What about dimensions beyond the fourth? Our source material mentions something called compactified dimensions, and it talks about string theory. Now we're getting into some serious theoretical physics.
But that's the exciting part. There's always more to discover.
Okay, I'm ready for more. Tell me about these compactified dimensions. Are we talking about tiny hidden worlds? Or parallel universes tucked away somewhere?
All right, imagine you have a garden hose stretched out across your yard from far away. It looks like a one-dimensional line, right? But if you get really close, you can see that it actually has a second dimension, curled up into a tiny circle.
So these compactified dimensions are like the tiny circumference of the hose, invisible unless you zoom in super close.
Exactly. String theory basically says that the universe isn't made of point-like particles, but of these incredibly tiny vibrating strings. And for these strings to vibrate in all the ways they need to create all the particles and forces we see in the universe, they need more than just the 3 dimensions of space that we're used to.
So these extra dimensions are like extra space for the strings to move around in. But why can't we see them?
Well, think back to the garden hose. The curled up dimension of the hose is so tiny compared to its length that you can't even see it from a distance. String theory says that these extra dimensions are curled up in the same way, but they're billions of times smaller than an atom.
So there could be entire dimensions hidden all around us.
Yeah.
Just too small for us to see.
That's the idea.
Wow, it's like there's this whole other universe happening on a microscopic level, right under our noses.
It's mind-boggling to think about what might be going on in those hidden dimensions.
It really is. What if they hold the key to solving some of the biggest mysteries in physics, like dark matter and dark energy? What if they could lead us to other universes? Or even allow for time travel?
Now you're thinking like a string theorist. It's important to remember, though, that string theory and the idea of higher dimensions are still theoretical. We haven't found any definitive proof that they exist. But scientists are working hard to figure out how to detect them.
This is all so incredible. And it makes you realize how much we still don't know about the universe.
Absolutely. But that's what makes science so amazing. It's a never-ending journey of discovery.
Well, we've definitely covered a lot of ground today. From the 4D reality of space-time to the mind-bending possibilities of extra dimensions.
It's been quite a journey.
It really has. And I think it's important to take a step back for a second and think about what all of this means for us. I mean, does knowing about space-time and higher dimensions actually change anything about how we live our lives?
That's a great question. And it gets to the heart of why we explore these big ideas in the first place. On a practical level, our understanding of space-time is used in technologies we use every day, like GPS. GPS relies on extremely precise measurements of time dilation, which happens because of both speed and gravity. Without Einstein's theory of relativity, our phones wouldn't be able to tell us how to get to the coffee shop.
Wow. So the next time I'm using GPS, I can thank Einstein for making sure I don't end up lost in some alternate dimension.
Exactly. And on a more philosophical level, thinking about these concepts can really challenge our assumptions about reality and free will. And even consciousness itself. It makes us question what we think is possible.
It's like we've been looking at the universe through a tiny little window. And now we're starting to see that there's so much more out there.
I like that analogy.
It's both exciting and a little scary.
It's a good mix of both, awe and wonder, mixed with a healthy dose of the unknown.
So, as we wrap up our deep dive into dimensions, what's the one big takeaway you want our listeners to remember?
I think it's the power of perspective. Our view of reality is limited by our senses and by what we currently understand about the universe. But that doesn't mean we should stop questioning and exploring. Who knows what amazing things are waiting to be discovered out there?
Beautifully said. So to everyone listening, keep exploring, keep questioning, and keep that sense of wonder alive.
The universe is full of mysteries.
And we're just getting started.
And hey, you might already be living in 4D and not even know it.
Thanks for joining us on this incredible journey into the world of dimensions. Until next time, keep looking up. And keep those minds open. It's like we've spent this whole time peeking through a keyhole, trying to catch a glimpse of this huge multidimensional reality that's out there beyond what we normally see.
I know what you mean.
It's kind of exciting.
But also a little bit scary.
Yeah. It's a big shift in thinking, going from our comfortable 3D world to the idea that there could be so much more that we just can't even grasp. Exactly. It's like finding out that the map you've been using your whole life is just a tiny corner of a much bigger map. And it makes you wonder, what else are we missing out on? What other crazy things are out there, maybe hidden in these higher dimensions, or even right in front of us, but we just can't see them because of our limited perception?
Wow, that's what science is all about, right? There's always something new to discover, some new mystery to solve. And even if we never actually see these higher dimensions ourselves, just thinking about them helps us understand the universe better.
I get that, but I'm curious about the practical side of all this. I mean, this is all mind-blowing stuff. But does it actually change anything for us here on Earth? Does knowing about space-time and higher dimensions make any difference in our daily lives?
That's a good point, and it's a question that scientists think about all the time. One practical example is GPS. GPS actually uses our understanding of space-time to work. It relies on these super precise measurements of time dilation, which is caused by both speed and gravity. If we didn't have Einstein's theory of relativity, our phones wouldn't be able to give us directions.
Wow. I had no idea. So next time I'm trying to find a coffee shop using GPS, I can thank Einstein for making sure I don't get lost in some dimensional rift.
Exactly. And beyond these practical applications, thinking about these concepts can change our whole perspective on life. It challenges our assumptions about reality and free will and what it even means to be conscious. It opens up our minds to new possibilities.
It's like we're explorers, setting sail into uncharted waters.
I like that.
It's both exciting and a little daunting.
That's the spirit. Awe and wonder, with a little bit of healthy uncertainty.
No. As we wrap up our deep dive into dimensions, what's the one thing you hope our listeners will take away from this?
I think the biggest takeaway is the importance of keeping an open mind. Our view of reality is limited by what we can see and hear and touch, and by what we currently understand about the universe. But that doesn't mean there isn't more out there. We should never stop questioning and exploring and imagining what might be possible.
I love that. So to everyone listening, keep exploring, keep questioning, and never lose that sense of wonder.
The universe is full of amazing things.
And we're just beginning to scratch the surface.
And remember, you might already be living in 4D without even realizing it.
Thanks for joining us on this incredible journey into the world of dimensions. We'll see you next time. Keep looking up and keep those minds open.